contact process. In the 17th century, Johann Glauber prepared sulfuric acid by burning sulfur together with potassium nitrate. And in 1736, Joshua Ward, a London pharmacist, used this method to begin the first large-scale production of sulfuric acid. But it wasn't until 1831 where the British merchant Peregrine Phillips patented a far more economical process for producing sulfur trioxide and concentrated sulfuric acid. This is the same contact process that we still use today.
The uses of sulfuric acid include the electrolyte in a lead acid accumulator, detergent, paint, production of fertilizers like ammonium sulfate, and plastics.
Molten sulfur is burned in dry air at around 1000 degrees Celsius. At this stage, only sulfur dioxide is formed. The oxidation produces large amount of heat. That heat is used to boil water to produce steam to generate electricity.
In stage 2, sulfur dioxide is converted to sulfur trioxide in a converter. The reaction is exothermic and is in equilibrium. A reverse reaction can occur, which means the product can break down into reactants. So here's the equation. The backward reaction will be favored at high temperature. Thus, to speed up the formation of sulfur trioxide and force the equilibrium to form more sulfur trioxide, a catalyst, vanadium 5 oxide, is added during this process. The reaction is also ensured to take place at 450 degrees and a pressure of approximately 2 atmospheres, as these conditions give a satisfactory rate without excessively compromising yield.
The third stage involves the conversion of sulfur trioxide and water to sulfuric acid. However, this process cannot be done just by simply adding water directly into the sulfur trioxide, as this forces the sulfuric acid to form a mist of tiny droplets. These are highly corrosive and does not condense so easily. So this process is achieved indirectly by initially dissolving the sulfur trioxide in concentrated sulfuric acid, as shown as the first equation here. The oily product is known as oleum. This can be reacted safely with water to produce concentrated sulfuric acid. And then, 99.5% of concentrated sulfuric acid is collected.
However, there are some acidic waste gases from here which can escape and cause local acid rain. So the chimney is fitted with acidic scrubbers. These are the bases like sodium carbonate. When in contact, they neutralize the waste gases, forming salt and water. The second way to reduce pollution is to recycle the gases between stages 2 and 3.
Let's move on to calculations. We're going to see the mass of reactants needed to produce 1 ton of H2SO4. So 1 ton of H2SO4 is equivalent to 1 times 10 to the power of 6 grams. The first step, calculate the number of mole of H2SO4, which is the mass divided by the molar mass. The second step, make sure all 4 equations are correctly balanced because they are interrelated. And finally, you can see that 2 mole of H2SO4 produced requires 1 mole of sulfur and 1 mole of oxygen. So the number of mole of sulfur and oxygen is the number of mole of H2SO4 divided by 2. The mass of sulfur required is the number of mole of sulfur times the molar mass, which you get 0.163 tons. And the mass of oxygen needed is equals to the number of mole of oxygen times 2 the molar mass. So you also get 0.163. So that is the mass of reactants needed.
Stage 1, when sulfur is burned in oxygen to produce sulfur dioxide. In stage 2, sulfur dioxide is converted into sulfur trioxide. In stage 3, sulfur trioxide is dissolved in concentrated sulfuric acid to form oleum. Oleum is reacted with water to produce concentrated sulfuric acid.
Presented by
Catastrophe!
Adeline,
Sam,
Natalie and Divya. Thank you.
Bye!